Hey everyone, let's jump right into this. Today, we're doing an explainer focused on the first three sections of Kyle McLean Smith's research paper, Hoesitive Universali. We're going to trace the journey from the physical realities of how light and matter move through space, all the way down to the pure, elegant algebraic geometry that actually governs it. Basically, we are talking about replacing infinite mathematical singularities with a flawless, continuous geometric bridge. It's a fascinating concept, so let's get into it.
Here is our roadmap for today. 1. Nature's perfect curve. 2. The photon limit. 3. The decay parameter. 4. The unit circle proof. And 5. Triangles in action.
Section 1. Nature's perfect curve. The dual superpowers.
To really grasp the foundational geometry of our universe, we have to start with a very specific shape. It's a curve that rules over both wave mechanics and classical optics, and it's called the cycloid. To visualize this in your head, just picture a standard bicycle wheel rolling down a perfectly flat street. If you put a glowing dot on the very edge of that tire and tracked its path through the air as the bike moves forward, that series of leaping arches it traces, that's a cycloid. It seems incredibly simple, right? But the physics embedded inside this curve are just astonishing.
See, the cycloid has two absolute superpowers in physics. First, it is a brachistochrone. That means it's literally the trajectory of fastest descent under a uniform force field. If you want to drop a marble from point A to a lower point B as fast as physically possible, an artificial straight line actually creates more friction and latency. The curved cycloid is always the fastest physical path, period. Second, it's a tautochrone. This means if you release an object from anywhere along this curve, it hits the bottom in the exact same amount of time. The time to convergence is totally invariant to where you start. It's basically nature's ultimate equalizer. So we've got this perfect physical curve for matter. But what happens when we look at light? What happens when this perfect curve is stretched out to its absolute limit?
Section 2. The photon limit. Approaching infinity.
When we're talking about the mechanics of a photon traveling through a uniform vacuum, we're really just looking at the geometric limit of that exact same cycloid. Let's walk through it step by step. As a specific mathematical variable, which we call the decay parameter d, approaches 1, the radius of our imaginary rolling wheel approaches infinity. And think about it. What happens to a circle when its radius becomes infinite? Its curvature completely vanishes to 0. The cycloid smoothly flattens out into a straight line. The absolute crucial takeaway here is that a straight line isn't some separate unrelated phenomenon. It is literally the exact same curve, just existing at its geometric limit.
Which brings us to this really powerful quote from the paper. Photons in a uniform vacuum travel along straight lines precisely because light obeys Fermat's principle of least time, executing pure geometry, distinct from unhalted floating point drift. Because photons are massless, they act as invariant constants. They don't need to take the curved physical path because they inherently exist at the infinite flattened limit of that geometry.
Section 3. The decay parameter. The geometric engine.
Okay, now that we've seen how light and matter physically ride this geometry, we need to look under the hood. We need to find the foundational mathematics driving the whole system, which all comes down to that decay parameter we just mentioned. To do this, let's ground ourselves with something super familiar, a standard right triangle. We have three variables here. A is our adjacent side, our horizontal base, and we usually anchor that perfectly to the number 1. B is the opposite side, which is our vertical rise. And C is the hypotenuse, which incredibly conveniently doubles as the radius of a unit circle that our entire triangle sits inside. So keep those in mind: base A, rise B, and radius C.
Using that triangle, we start with a standard baseline from trigonometry, the fundamental tangent half-angle identity. That identity is tangent of theta over 2 equals A divided by the quantity C plus B. This is our launchpad. Our goal now is to simplify this fraction to unlock our pure mathematical engine. So let's walk through the algebra together. I promise you this is remarkably elegant. To get rid of that clunky addition in the denominator, we're going to multiply the top and the bottom by the conjugate, which is C minus B. The top becomes A times the quantity C minus B. The bottom becomes a classic difference of squares, C squared minus B squared. And here is where the magic trick happens. Thanks to the Pythagorean theorem, we already know that C squared minus B squared is exactly equal to A squared. So we just swap it right in.
And that leaves us with this beautifully simplified result. The A on top cancels out one of the A's on the bottom, leaving us with our decay parameter, D, equaling C minus B all over A. This tiny, perfectly rational difference of squares identity is the engine for the entire framework.
And remember, if our base A is firmly anchored to 1, then the parameter d simplifies even further to just c minus b.
Section 4. The unit circle proof, the algebraic climax.
So we have our engine. But how do we actually prove that this right triangle geometry flawlessly aligns with the broader reality of the unit circle? The premise is pretty straightforward. We want to find the exact vertical height, the y-coordinate, of a column built out of our geometry. This total height y is defined as the vertical rise of our triangle, which is b, plus the height of a rectangular capping block sitting right on top of it. And that block's height is defined as our base a times our decay parameter d. So our equation is y equals b plus a times d.
Now pay close attention to what happens when we substitute our newly discovered decay parameter into this equation. We replace d with c minus b over a. Look at how beautifully those a variables are positioned. We have an a multiplying a fraction that has an a right there in the denominator.
They instantly cancel each other out. That leaves us with y equals b plus c minus b. Naturally, the positive b and the negative b cancel each other completely out too, leaving us with an undeniable final result, y equals c. We have just mathematically proven that the exact height of our rectangular coordinate column is pinned flawlessly and directly to the crown of the unit circle at height c. There are no infinite decimals here. There's no transcendental drift. It's just pure, precise algebraic alignment.
Section 5. Triangles in action, the visual evidence.
If you're anything like me, you want to actually see this math working in the real world. You want to see the shapes. So let's translate this abstract algebra into undeniable visual evidence. Let's take a look at a classic Pythagorean 4-3-5 right triangle configuration. Our base A is normalized to 1, written here as 4 over 4. Our vertical rise B is 3 over 4. Our unit circle radius C is 5 over 4. Now recall our engine formula. The capping block height is C minus B. So 5 over 4 minus 3 over 4 gives us 2 over 4, which simplifies to a height of 1 over 2. When you stack the rise b, which is 3 over 4, and the capping block, which is 2 over 4, you get a total exact height of 5 over 4. The coordinate column perfectly strikes the crown of the circle at radius c.
But what if we completely flip the proportions? Let's check out the complementary 3-4-5 configuration. This time, our base A is 3 over 3, keeping it anchored to 1. The rise b is now a taller 4 over 3. The radius c is 5 over 3. Let's run our geometric engine again. C minus b. 5 over 3 minus 4 over 3 gives us a capping block height of exactly 1 over 3. Stack the rise of 4 over 3 plus that block of 1 over 3 and you get 5 over 3. Once again, the geometry perfectly, flawlessly aligns with the crown of the circle at radius c.
Seeing these two setups side by side really drives home just how elegant this framework is. It literally doesn't matter how the dimensions of the internal triangle shift, the algebraic alignment holds up perfectly every time. The mathematical engine of the cycloid, defined by that simple decay parameter, acts as a universal geometric reality. It links right triangles with unit circles in completely rational, finite terms.
Which leaves us with a truly profound question to think about. Standard quantum electrodynamics, or QED, notoriously struggles with mathematical infinities because it relies heavily on zero-dimensional point singularities. But if this continuous, non-infinite logarithmic bridge, which is built on the exact, provable geometry of light and matter, can flawlessly replace those infinite limits with deterministic, perfectly halted boundaries, how does that change our modeling of the quantum universe? It's a massive paradigm shift. It suggests that the physical world might not be built on unhalted infinities at all, but on brilliant, rational geometry. Thank you so much for exploring this with me today. Keep questioning, keep learning, and I'll catch you on the next explainer.